Hello everyone, and welcome back to another video on quadratics. Today we're looking at completing the square. Completing the square causes most students absolute headaches. It's one of those topics where it actually isn't that difficult, but you have to practice it quite a bit to get pretty good at it. Now, there's many different ideas for how we can complete the square. I have a bit more of like a formulaic approach. I can explain a little bit about why we complete the square. The main reason we complete the square is because I want to factorize my quadratic typically. That's where the idea for this can start. Right? There's two main reasons. One is I'm trying to factorize. If I'm trying to factorize this quadratic, we know from previous videos that if I do x squared plus 4x minus 1, I'm looking for two numbers that multiply to give -1 and add to give +4. If I do that on this quadratic, there is no pair of numbers that multiply to give -1 and add to give +4. I should say there's no whole numbers that multiply to give -1 and add to give +4. So we are left with a situation where we can't factorize using our normal methods. We have to have a different process. One of the options is quadratic formula, which we'll cover. The other option is completing the square. So what completing the square means is it essentially takes the idea of, well, what if instead of having -1 on the end, what if this quadratic instead looked like, I'll put it in pink, x squared. That's pretty hard to see. I won't put it in pink. I'm going to put it in green. If I have x squared plus 4x plus 4, so instead of +1 on the end, if I had a +4 instead, well, now I could factorize my quadratic, and I factorize it very neatly into a perfect square. So again, I do two numbers that multiply to give +4. That gives me 2 and 2. So I wind up with my brackets of x plus 2 multiplied by x plus 2, which we can simplify to give x plus 2 squared. I have a perfect square. So we take this idea of, oh, wouldn't it just be awesome if this number here was +4 instead of -1? Because we want that to be the case, we now kind of force the equation, or we manipulate the equation to make it look more like the new equation I've written on the right-hand side. So instead, I'm going to take it, so I'm going to get rid of this red circle too, because it looks very messy. I'm just going to delete that. And I'll get rid of my little green bit here as well. We take that idea, and what we do is, I'm going to zoom in here a little bit. What we do is I rewrite my equation, x squared plus 4x. I'm going to add in that +4 that I know I want, because if there's a +4 there, like we saw over here, I can factorize to x plus 2 all squared. So I'm going to add this +4 in, but I can't just add stuff into my mathematics without breaking the math. So if I add 4, I also have to take away 4. If I just look at this little part here, I've added 0 to my equation. I've added 4, I've subtracted 4, there is nothing actually added to my equation, and my -1 here on the end is going to stay the same. So what I've done by adding 4 and then taking 4 away is I have manipulated my expression. I've changed my expression, my quadratic, so now I'll get rid of this. So now if I just look at the first 3 terms, if I just look at x squared plus 4x plus 4, I can see that this is going to factorize very nicely. In fact, this factorizes into, as we just saw, this becomes x plus 2 multiplied by x plus 2, and then all this part here on the end, I'll put this part in red, all this part on the end, which I normally think of as the tail, that is also just going to stay here on the end of my expression. If I simplify x plus 2 multiplied by x plus 2, this gives me the equation of x plus 2 squared, and then -4 minus 1 gives -5, and I've now completed the square on the quadratic x squared plus 4x minus 1. However, that was all quite slow, and how do you know which number to add? There's all these little questions that come out of this. So we're going to talk about what is the method that we can use to get this answer quickly, efficiently, every single time. Okay, this is sort of the theory for why it works. There's two things I really want to point out. I've taken 3 terms, I've taken these 3 terms here, and I have turned it into a perfect square factorized to x plus 2, brackets, all squared, and I've subtracted my tail on the end. I'll put this bit in red here. This part has stayed the same the whole time. I'll put this bit in yellow. This part has turned into this part here. So my yellow goes to my yellow, my red goes to my red, and this is my final result. Now, how do I know what number to add into my quadratic? Well, I have a bit of a rule, or a bit of a formulaic way we can get to our answer. The rule I like to use is this idea of b over 2. Okay, so if I know my general form for a quadratic, that is ax squared plus bx plus c, b, my middle term, what I'm going to do to get my number, in this case we identified we had to have the number 4, right? To get that number, I take my b term, whatever my b term is inside my quadratic, I divide that by 2, and I square the whole thing. If I do that in this question here, I wind up with 4 over 2 squared. Well, 4 divided by 2 gives 2. 2 squared gives 4. The numbers are the same in this case, okay? Now, it's kind of a bad example from that sense because this is a complete fluke. These numbers are never going to be the same outside of this one specific option where it's 4x, okay? So that's where the number 4 comes from. It comes from halving my b term, squaring it, and I'm going to add that back into my equation. I'm going to do this with a different example. And then we'll talk about how we can speed this up a little bit, how we get down to a nicer solution. So let me just grab this stuff I've got here. Okay, so the new question I'm going to do, and sorry if that's a little bit small, the new question we are going to do is simply x squared. We'll keep it mostly the same. I'll do plus 6x. I'll just do plus 2 on the end. Okay, so this is the sort of the new quadratic we're going to complete the square on. So how I identify that number is I take my b term, I divide that by 2. I square the whole thing. In this case, this is going to give 6 divided by 2 all squared. That is going to give me 3 squared. Now, how I like to do this, and this is the way we can do this the quickest, fastest way possible, is instead of making this number 9, I'm just going to leave this as 3 in brackets all squared. The reason for that is, and we'll see this in the second example, as soon as I start getting into odd numbers, where I'm going to have fractional answers, it gets very messy to expand, adding fractions in. It's really, it adds to the challenge. It doesn't make it easier, it makes it harder. So, if we have a look here, I'm just going to leave it as, in brackets 3 squared. I'm going to rewrite my equation. That means I have x squared plus 6x. I'm going to add in my 3 squared. I'm going to take away my 3 squared. And then I'm going to add my plus 2 on the end. This is my quadratic. I now saw before that I can factorize my first 3 terms. Okay, so I can factorize these terms here. I might keep my colors the same. I'll keep this in yellow. I can factorize those 3 terms. Now, instead of having to think every single time, okay, what 2 numbers multiply to give 3 squared, add to give 6, what you might notice is, well, 3 plus 3 gives 6, 3 squared gives 9. By keeping the number in the brackets, I've actually identified my factor straight away. So I can now factorize immediately, and what I wind up with is simply just x plus 3, x plus 3, and I've got my tail part that is minus 3 squared, plus 2 is going to stay on the end. Again, my x plus 3 times x plus 3 is going to give x plus 3 squared. And then I've got minus 3 squared, which gives 9, plus 2 is my tail. If I tidy that up, I get x plus 3 all squared minus 7. And I've now completed the square. Again, this process takes a little bit too long. I can go from here straight to here pretty consistently. I can actually get to the answer if we can do a little bit of mental math adding our tail, or subtracting our numbers for our tail. But we can go from here to here very quickly. We don't need to include this step. We don't need to include that line at all. We can go from our quadratic straight to our answer. And if we notice the pattern that happens, is essentially what happens every single time. And I need to get rid of some of my highlighters so I can re-explain some of this, okay? What happens every single time, and the pattern that emerges, is this number 3 here appears here straight away, or here, right? It's in 2 spots, it's the same. It's positive 3, so it appears as positive 3. My x term is always going to stay as x, and I can't complete the square on any quadratic that has a number, any non-monic quadratic. I can't complete the square. I need to make all my quadratics monic, so I'm always going to wind up with my x term here. The tail bit is simply just going to be, well, b over 2 squared, and this plus 2 part here is part of my original question. So the formula we can have for how we get to our completing the square term, or the way I like to do this fast, is the formula we wind up with is to complete the square, it becomes x plus b divided by 2, whatever that term is. I square that, I'm going to minus b over 2 squared, if you can see that there, and I'm going to add c. Now remember, c comes from my original form of a quadratic. This is the b, the c term. This comes from ax squared plus bx plus c. So any quadratic, I can do this formula. I can take x plus b over 2 squared minus b over 2 squared plus c. This is the formula, or the formulaic approach to how we complete the square. Where the formula is good is when the numbers are a little bit awkward. And we'll do some awkward numbers in the next question. I've got my quadratic. It is x squared minus 7x plus 1. Okay, so I'm now going to complete the square. I've got x squared, or is it plus or minus? Minus 7x, x squared minus 7x plus 1. And I have my formula that I wrote out before, which is x plus b over 2 squared minus b over 2 squared, a bit of a messy 2 there, apologies, plus c. If I look at my terms, I've got a equals 1, b equals minus 7, and c equals 1, just so we can see how that is going to interact with my rule. If I factorize using completing the square, using the formula, I wind up with x plus, well, in this case, b is 7, so I wind up with minus 7 over 2, and I realize I have a positive here and a negative here. I said that the wrong way around. I got a positive and a negative. That is simply going to turn into a negative, so I'm just going to erase all of this and write that simply as x minus 7 over 2. I'm going to square that. I'm now going to subtract 7 over 2, or minus 7 over 2 all squared, and I'm going to add 1. Now, negative 7 over 2, you might ask why include the negative sign here? I know if I square it, it's going to become positive. That's more so we can see that's also why I get a negative inside my brackets as well. Now, if I just basically clean up the tail, I don't have a fraction inside my brackets. We don't mind. We can have fractions inside our brackets for completing the square. It's super common. We're happy with having negative 7 over 2 here inside my brackets. So all I have to do now is clean up this part here at the end, this part here, which I've been doing in red before, the sort of tail part of the question. I tidy that part up and I have my answer, which is simply just x minus 7 over 2 squared, minus 7 squared gives 49, 2 squared is going to give 4 plus 1. Well, if I can add fractions and a whole number, we should see I get x minus 7 over 2 squared minus 45 over 4. And we love improper fractions, so we will leave them as improper fractions. And that is how I complete the square super fast for awkward numbers. I have my formula, x plus b over 2 squared minus b over 2 squared plus c. Works every single time, works super fast, and it's how I would recommend completing the square question. Any comments, feel free to let me know down below. I'll see you guys in the next video. Enjoy, guys. Goodbye.